All right, so in 8.1, obviously we reviewed the names of the polygons, right? You need to know the names of all the polygons, the special polygons, like 1 through 12, or not 1 through 12, 3 through 12, skipping 11. And then we talked about 4 equations. One, well, sort of equations. One, which is the sum of the interior, which is what? Good. N minus 2 times 180. And then we said each interior, and that had to be of a regular polygon, and that's what? Good. Then we did sum of the exterior, which you're not going to get wrong, right? Because it is 360. And then each exterior, again, if it is a regular polygon, and that's what?
360 divided by n.
Good. So those are the 4, I mean, one's not even a formula, but those are the 4 things you have to know in addition to the polygons. So this one said, find the sum of the measures of the interior angles of a convex 24gon. So we want to look for words like sum or each. This one says sum, and we want to look for words like interior, exterior. So which formula am I going to use?
N minus 1 times 180.
Good. And n is 24, right? So 24 minus 2 times 180, or 22 times 180. And then add on my 0. 3,960 degrees. Raise your hand if you got that one right. Okay, good. All right, then came the sum of the measures interior angles of a convex polygon is 5,040. So instead of it giving you the number sides and you giving it the angle, it's giving you the angle, which means n minus 2 times 180 equals 5,400 or 5,040. So then I know this is going to go evenly because you can't have an n that's a decimal. So I'm going to divide first. These cancel, and then this is twice. Six, is that right? Not 0. Oh yeah, that was right. That's not right. That's 8. Yes.
Wait, I just...
So 28. You do what?
I got the same.
Okay. So n is 30.
I like distributed and I...
That's fine. Yeah. It just will always give you a whole number. So if you want to divide first, you can. Because like 180 is smaller than dividing by 360, but it will always give you the same answer. Yeah. And it will always be a whole number if it's asking for n. Good so far? Yeah? Okay. Then came 3. It says to find the value of x. So what are all those angles?
They equal to 360.
Good. They're all exterior, which means they add up to 360. So 72 plus 46 plus 110 plus x plus 3x equals 360. So if I added that's 156 plus 72, 228 plus 4x equals 360. Subtract the 228. Thank you. 132. 33, which is what they're looking for, the value of x. Oops. And then 4 says, find the measures of the interior angle and the exterior angle of a regular 36gon. So 2 questions here. Measures of n, which is 1 interior, n minus 2 times 180 over n. And then n exterior, which is 360 over n. And n is 36. So this is 36 minus 2 times 180 over 36. And this is 360 over 36. So this one's easy. That one's 10, right? This one becomes 34 times 180 over 36. And last week we said you can multiply out the top and then divide, or you can start to simplify. So I could say 9 easily goes into each of those, right? That'd be 20. And 4, I can keep going. That's 5 to 1. And then all I have to do is 34 times 5. Just be careful when you do that so you don't cross out the wrong thing. But again, you could have done the same thing by doing 34 times 180 and then taking that answer divided by 36. It's just sometimes we're better at simplifying easier answers than 3 is 33. All right.
And then X here would be just 10.
X here is just 10. Yep.
Can you just make it equal to 180?
Yeah, if you get 1, if you already have the interior, then these two have to add up to 180. You can also just subtract it from 180. Most likely, quiz-wise, you won't get both parts. You'd get them separated out. Yeah. These are exterior angles, just like that warm-up, right? So they're going to sum to 360. So I would do x plus 77 plus 40 plus 45 plus 2x equals 360. 3x, this is 85 plus 77, 162. $198. And measure 66. So remember, if they're on the outside, 360. If they were inside, I'd have to figure out what the sum is and then subtract them off. One said the outline of the playing field of the baseball park is a polygon as shown. Find the sum of the measure of the interior. So I have to count 1, 2, 3, 4, 5. That's n is 5. 5 minus 2 times 180, or 3 times 180, which is 540. So just be really careful. Like, it stinks to know what you're doing but answer the wrong question because you're not reading carefully. Like, if it was me, I'd start to circle words like sum and interior and exterior, that kind of stuff, so you know what you're looking for, because all that stuff's obviously going to get blended in. Everybody good on 8.1? Okay, so 8.2, we narrow it down to just parallelograms. So in 8.1, it was like all of the polygons, right? Now we're going to talk about parallelograms, and we're going to learn a bunch of properties of parallelograms. And then 8.3 goes even narrower into rhombuses, rectangles, and squares. Mateus.
For learning properties, are we going to do like some two-column proofs or something like that?
You might see it smatteringly in here, not heavy like it was before, okay? It's more of an application of a property than a heavy focus on the proving. However, 8.3 is, 8.3 is not rhombuses and rectangles, sorry. That's 8.4. 8.3 is proving quadrilaterals or parallelograms, so we're going to flip it, okay? As bad as they used to be. So a parallelogram, by definition, is a quadrilateral with two pairs of parallel sides. So the opposite sides are parallel by definition. We use this little shape that looks like a little slanted rectangle to say parallelogram. So when you see that shape, that means parallelogram. And when you're lazy and you don't want to write out the word parallelogram, or you forget how to spell it like I do all the time, you can put that little shape, okay?
But it has to be slanted, right?
Yeah. You don't really have another shape like that. Like we don't use one for rectangle.
Or square.
No, it's just parallelogram.
But a square and a rectangle are parallel.
Yeah. Yep. So in this shape, AB would be parallel to CD and BC is parallel to AD. Opposite sides are parallel. Then we dig a little deeper. This, and it's a theorem, but it's really just a property, says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So we're going to learn a bunch of properties of parallelograms. The first is its definition, which is opposite sides are congruent. Opposite sides are parallel. This is opposite sides are congruent. So in this diagram, AB would be congruent to CD, and BC would be congruent to AD. Then we learned some more. If a quadrilateral is a parallelogram, then the opposite angles are congruent. So in this shape here, angle B would be congruent to angle D, and angle C would be congruent to angle A. And if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So consecutive, think about when we went back to parallel lines and consecutive interior angles. If these are parallel and this is a transversal, then the two here, this one and this one, would be same side interior, consecutive interior, which makes them supplementary. This happens 4 times as I move around a parallelogram. So this and this would add up to 180, these two. Then these two would add up to 180. These two would add up to 180, and these two would add up to 180. So as you move around your parallelogram, either clockwise or counterclockwise, each pair you run into would sum to 180. Okay, and then the last property of a parallelogram is that if it's a quadrilateral is a parallelogram, its diagonals bisect each other. So the diagonals are going to connect the non-consecutive vertices. They go straight across, making an X. And they bisect each other, which means in this diagram, BZ would equal ZD, and AZ would equal ZC. The diagonals are not necessarily the same length, right? Because the bigger the slant on a parallelogram, if I slant it a lot this way, this is a super bad drawing, but if I slant it, that's definitely not the same length as that. But when you chunk it up, this is the same as this, and this is the same as this. So the more of the slant, the further off the diagonals are going to be. They're not going to be the same length, but the individual diagonals will be cut in half. So that's 5 things. So that's 5 things we know about a parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and consecutive angles are supplementary. 5 properties of every parallelogram. As soon as you see it, you know those 5. Okay? Now we're going to... So this says, name all the pairs of parallel lines, name all the pairs of congruent angles, and name all the pairs of congruent segments. This, obviously, has to be a parallelogram to answer these questions. So we would say... in parallelogram A, B, C, D. All right, so give me a pair of parallel lines.
BC and AD.
BC is parallel to AD. And?
AB to DC.
Good. AB is parallel to DC or CD. It doesn't matter the order of the letters, don't matter there. Number 2, name all the pairs of congruent angles.
B super D.
So because it's divided into parts, we got to use 3 letters, right? So if I want to do this angle and this angle, I can say angle ABC is congruent to angle CDA or ADC,
Oh yes, it says more than one.
right? Because we divided it. What else? You've got vertical angles, so this would be congruent to this. I can say BEC is congruent to AED, and this is congruent to this. AEB is congruent to DEC. Got one more. What's the other pair from my parallelogram?
You have angle ADC to angle. Wait, where is it?
Yeah, the other corners, right? These corners.
And then DC.
Good. BAD. BCD. So there's still vertical angles. Yep. They're all that stuff. These are still a linear pair in here. Like there's a bunch of stuff that still applies. Okay, then give me the pair of congruent segments.
You have BE to ED, AE to EC, BC to AD.
You're right. You're saying faster than I can write. What was the next one you said?
BC to AD.
BC, AD, and one more?
AB to CD.
Good. So you've got your opposite sides that are congruent, this one to this one to this one, and then you've got your diagonals that are bisected, this to this, and this to this. Good job. Questions so far? Now let's get some values on there too. All right. RSTU is a parallelogram. Find X, Y, A, and B. So let's look at A first. What's the value of X? Why is that?
It's opposite of
Good. Opposite angles are congruent. What's the value of Y? That is not true. 100. Why is it 100? Good. These are supplementary and these are supplementary. Okay, now, nothing. Now, what's B? There's no A this time, right? What's B? 9, because these are congruent. If there was an A on the other side, A would be 6, right? Good so far? Yes? Okay. Now, X is this one here. This whole angle. Sorry, that whole angle. We're not ready to split it yet. Okay. So, how do I get there? How do you know that?
Because 45 plus 35 is 80, so that'll be supplementary, so it'll be 90.
Good. That's 80. That makes that 100. Because those would be supplementary. Everybody understand that? Yeah? Okay. How am I going to get this guy?
Opposite angles. So it'll be
So this whole thing equals this whole thing, right? That's 80, but it only wants this part.
35.
Alternate interior, it's 45. Good job. Right? This matches this because these are my parallel lines. And this, actually no, these are my parallel lines. And this is my transversal. Yeah, alternate interior. Okay, and then now I have an A. A is what? 12. And B is? 9. Good job. Okay, a little bit of algebra brought in on C. So what's true?
Is X
13
100? Is X
equals 3y plus 4, and 8 equals 4x.
Yeah. 4x equals 8, right? Those are opposite sides. Those are congruent. And then 3y plus 4 equals 13. So x equals 2, 3y equals 9, and y equals 3. Here's what people love to do. Take all of these, add them together, set them equal to 180. Or take these two and add them together, set them equal to 180. You know nothing about the sides being equal to 180, right? So be careful. Questions? Anybody still coming down? They're back. No. Find the perimeter of PINE if PI is 12 and IN is 8. So, draw yourself a little picture if you need it. It doesn't matter where you put the letters as long as you go clockwise or counterclockwise. So I could have put P in the top right and wrap myself around. Doesn't matter. So PI is 12. IN is 8. We know opposite sides are congruent, so there are two 12s and there are two 8s. So you can either add them up, or it's twice length plus twice width because the lengths and the widths are the same. So you could have done either one. 2 times 12 plus 2 times 8. Or this is 20 and this is 20. Either way, perimeter is 40. Yep.
Can you go back to the second
Mhm.
theorem?